All right, guys, we're going to start balancing reactions. Why? Because it's the law of conservation of mass. It's the law. You better obey it, right? Okay. Let's take a look at some equations that are in your notes. Try to balance them yourself. See if you can jog your memory on how to do that, and come back to me. Okay, welcome back. uh, for uh, for that first one, it's a combustion reaction. So they're typically the most difficult for students to learn, but they're not too bad when you figure out the process. Always balance your carbons first. So carbon's already balanced, so let's balance our hydrogens. We put that 2 right there, and then we'll balance our oxygens last. Okay, so hopefully you figured out the second one. That one was pretty easy. The third one is also a combustion reaction, so I'll balance my carbons first by putting the carbon here, the 5 here. Then I have to balance my hydrogens, and I put a 6 there. And so that's going to be 10 oxygens here, and then 6 oxygens, so 10 plus 6 is 16. So I can make 16 out of here. So what if I came up with an odd number? That could happen. So if I ended up having, instead of 16 oxygens, I had 15 oxygens. Well, I could put 15 halves right here. That would work. That's actually possible. You're allowed to do that on IB. So for this one, you're going to put a 2 here for to make 2 ammonias. And then you're going to have to put a 2 there to make 2 ammonias. We put that 2 originally there to balance out the hydroxides, the OHs. When you look at these, try to look at them as a group. So let's see if I can use my pen here. You're going to look at those hydroxides as a group and these hydroxides as a group. You're going to look at the ammonia and the ammonium as a group. Okay, they're much easier to balance instead of looking at nitrogen specifically or hydrogen specifically. And then, so for the next one, this is a V2O5. So we're going to put a 5 there, balance out the oxygens. We're going to leave the single ones for the end because they're easiest to balance. We'll put a 5 and a 2 there. And then for this one, we got to put a 2 here. We unbalanced our sodium, so let's go ahead and fix that with a 2 there. Piece of cake. So these types of reactions right here are going to be different than pre-AP. When I taught you that there were 5 different types, there's actually 3 now, 3 types of reactions that IB wants you to recognize. This one is a redox reaction. That's an oxidation reduction reaction because oxygen is oxidizing the hydrocarbon. This one is going to be a precipitate or precipitation reaction. So you see you're forming a solid precipitate here from 2 aqueous solutions. That's a dead giveaway for precipitation. This one's also going to be redox because it's a combustion reaction. This one is actually an acid-base reaction. You can tell by the OH right here that that's probably a base, and this is a very weak acid. So this is an acid base. This is a redox. This is a redox. You can tell them because the single replacement ones are always going to be redox. The oxidation state here is 0, but the oxidation state here is +1, if you remember that from last year or the year before. So the oxidation states change. That's why they're called redox reactions. So we'll get to that more later if that's really freaking you out. But check out the mole. We're going to kind of fuse into 2 videos here where we're going to look at the mole. The mole is an amount of substance. It's the number of substance. It's a very big grouping of substance, and that's comes from the Latin word heap or pile. So it's a pile of stuff. So much so that a mole is a huge amount, 6.02 times 10 to the 23rd. Particles or things make up 1 mole of that. So if you had 6.02 times 10 to the 23rd elephants, you'd have a mole of elephants. Okay, kind of like a 12 is a dozen of eggs. Same thing. Okay, hopefully we remember that. Now, it comes from the exact number of atoms there are in 12 grams of carbon-12. This little nomenclature right here, from where it comes from, I'd be expecting you to know that. So let's talk about that calculator that happens. You don't get a calculator on paper one. Sorry, paper one is still happening as far as August 16th, 2020. Paper one will happen. It's a multiple choice exam. Paper two will happen where you will get a calculator. So just paper one, you're going to have to do mental math. We'll practice this. Don't worry about it. The numbers are usually pretty nice and pretty easy, but if you can do mental math, try working it out on your own. So that will happen a little bit here, and I'll point out a couple examples. So we're going to look at percent composition by mass. This is a real common paper one question. So where they ask you to calculate the percent composition of mass of magnesium nitrate. Well, I gave you the formula already, but you should know that magnesium is a +2 charge and nitrate is a -1 charge. You should also know that nitrate is NO3. So if you don't know that and you don't know your charges, you need to go back and review your charges in your polyatomic ions because those will be necessary. So anyways, you come up with the formula here. And so now we can find the molar mass, the total molar mass of that. So the percent composition is just the part over the whole, right? So we're going to find the part, we're going to find the magnesium, which is 24.3, the molar mass of magnesium, divided by the whole molar mass of magnesium nitrate. And that's going to be, and we'll do the same thing for nitrogen. Sorry, I'll hold my answers for the end. And we'll do the same thing for oxygen. For nitrogen, there are 2 nitrogens, so we need to multiply nitrogen's molar mass by 2. We need to multiply oxygen's molar mass by 6. Okay, notice that we're still dividing by the whole thing. The denominator doesn't change. When you plug those in the calculator, you get these percentages, and that's what you should find. Now, if it's a multiple choice test, you'll have the options in front of you. So you could obviously find out that if it said, if you could at least get to this stage right here and at least get approximate numbers here, you would know that oxygen is the highest numerator. 6 times 16 is definitely higher than 24 or 2 times 14, right? So you know that oxygen is the highest. Well, then you should be able to eliminate answer choices where oxygen is not the highest, right? Okay, so hopefully you'd use some test taking strategies here. Okay, so for example 2, exactly the same. Try to work it out on your own. I'll pause. I'll wait. Okay, welcome back. So we want to calculate the percent composition of mass by ammonium sulfate. Hopefully you found this formula, ammonium sulfate. And because ammonium is +1, sulfate's -2. So you crisscross the charges and you get that formula. The total molar mass is here. We find our calculations here. Same thing, all dividing by the total molar mass. And then we all have our respective molar masses at the top. Make sure you multiply by the number of atoms there are. There's 2 nitrogens, there's 8 hydrogens, there's only 1 sulfur, there's 4 oxygens. And you should get these numbers. And that's pretty much it. That is it for percent composition. It's really simple. And if you're good at mental math, this is going to be your strong suit. Okay? Should be an easy question.